Hi guys, this video today is going to be about half-life, and I guess the opposite of that would be double life. We don't really call it that, but doubling time is something that we look into. But half-life is basically how long it takes for something to be halfway gone. Here are some examples: radioactive decay, medicine in your body, etc. Each of these has a certain formula or a certain number for how long it takes for that element to be halfway gone. And so if we look at some equations, this is the equation that we were using before. This is the half-life formula. You can see they are very similar. A still stands for the ending amount. P is the principal, the starting amount. The R is the rate. The T is the time. The only thing new over here is that H stands for half-life. All of the rest of these variables apply to this case as well, just that H is that half-life. And so let's talk about how to set these up, how to work them out. First of all, how to read the equation. Some people have a hard time reading the sentence. Some people have a hard time reading through the sentence. So the half-life of a mythical stone is 5,200 years. That is H, that's your half-life. The stone originally weighed 750 pounds. That's your starting amount. 700 years ago. How much does it weigh today? The 700 years ago, that is your T. That's the time that we're talking about. So let's just start off with our basic formula and start plugging things in. As far as A, we don't know what A is. That's what we're looking for. P is the principal, how much it started with. In this case, it started with 750 pounds. The rate is 1 minus the rate, which is 50%. We're talking about half-life, so you're losing 50%. And the time is going to be 700, and we take that 700 and we divide it by the half-life, which is 5,200. So now we're going to put that into our calculator. One thing is, on our calculator, we could simplify this equation to just a 0.5 to the 700 over 5,200. And that 0.5, that's the half-life. So this 1 plus or minus r is always going to be 0.5. All right, let's go to our calculator and see how we put that in and what it's going to give us as an answer. Okay, so I'm just going to put it in, and I'm just going to put it in exactly as it is on my paper. I want to use those parentheses. I'm just going to do the exponent button here above the division sign and put that in and put that into the exponent. And now I'm going to hit enter and see what it gives me. 683.18. That is the answer of how much does it weigh now. Let's just take a minute and talk about reasonableness. Is this a reasonable answer? Okay, if it weighed 750 pounds to start off, well, half of 750 is 375, right? So that would mean in 5,200 years, it's going to be 375. We haven't reached that point yet, so it should be in between 375 and 750, and it does come out to be that. So that is a reasonable answer in this case. Okay, this next problem. Similar deal. Take a second to read it through, decide what all your variables are going to be, and then set it up into an equation. Okay, so when you plug in the numbers, your A is 1.5, your P is 2 grams, your rate is 50%, this is half-life, and 8 is the half-life. So this is what we are going to put into our calculator. We are solving for T. Now, we did this last week a little bit also, but we're going to continue that. For now, we're just going to use a table. So for now, we're just going to use a table to solve this. It's actually not solving, it's just scrolling through the table. Next week, we are going to learn how to solve it. That involves something called logarithms, and we haven't learned logarithms yet, but that is next on our agenda for next week. So when I plug all this in, I'm going to have to do a couple things to solve this. But mainly, what I'm going to do is I'm going to not put in the 1.5. That is actually what I'm going to look for in my calculator. So instead, I'm going to put in y equals 2 times 0.5 to the t over 8 into the calculator. And also, just a reminder, we do not multiply these first. Order of operations says you do exponents before you multiply. So you don't multiply these to get 1. You do this first, and then you multiply that times 2. But let's go to our calculator. We're going to put this into the y equals button. Okay, so I'm going to do 2 times 0.5 to the power of x over 8. Okay, I'm going to go to my table, and what I'm going to be looking for is when does y get to be 1.5? I know that my table's kind of messed up right now, so I'm going to look at what I have in my table, and then I'm going to go to table setup because I've been doing a bunch of different stuff, so I need to change this table. I'm going to go to second table setup. I'm going to start at 0, and I'm going to change by 1, and I'm going to look at my new table now, second table. And I'm looking for when does it get to 1.5. And it looks like right here, right about a little bit after the third year. I could zoom in more by changing my table to count by 0.1s, but at this point we're just going to say between years 3 and 4, and then like I said, later we'll figure out how to solve that, but right now let's just say between years 3 and 4. And that's how long it's going to take. Okay, let's turn the page. Okay, a similar problem. This one we will be able to solve. We do know how to do this. But again, let's look through the problem, decide what to label things. Okay, so we're going to use this formula. We're going to plug these in. A is 167. They're telling you that's how much you have, and they're wanting to find out how much did you start with. But that is what the A is 167. So we're going to put 167 over here. Okay, now this one we can work on solving. In our calculator, we can take 0.5 to the 6 over 15 power and see what we get. So I'm just going to take 0.5 to the power of 6 over 15. And that gives me 0.7578, etc., etc. So I'm going to go back to my paper, and I'm just going to round that as 0.758. And so now if I divide by 0.758 on both sides, I will get my answer, which comes out to be 220.36. And we probably want to look and see what units we're in. We started with milligrams, so this is going to be measured in milligrams. So the starting amount, you started with 220 milligrams of Aleve. Let's look at part B. The second part, how much is left after 24 hours? Well, this time, we need to solve for A, because now we know what our starting amount was. Our starting amount was 220 and 36 milligrams, and we are talking about half-life, and it is now, the question is, after 24 hours, when the half-life is 15. So we're going to put that into our calculator and see what you get. Put that in and see how you do there. Okay, when you take that decimal, you get 0.3299. You multiply that by 220, and you get 72.69 milligrams, which is left after 24 hours. And if you think about taking medicine, because all medicine says, you can take more after 6 hours or 24 hours or whatever, that doesn't mean the drug is gone after that amount of time. It just means it's gotten to a low enough point that it's safe now for your body to take more in. So even 24 hours later, you still have some of that left in your body. Something to think about. At the bottom here, I just have a reference to coolmath.com. That is a site that I think is pretty helpful, pretty useful on coming up with some information. So if this was a concept that you needed some extra time on, then you could do this. She has it written out 2 different ways. They both mean the same thing, though. But you can always look into that if you want to look into that. Once again, there are some lines for summary. That is up to you if you want to write some things down for the summary.